Hello there! Do you happen to have troubles with engaging your students in your math classes? Well, you came to the right place. This video would teach you how to create an instructional material that would help you in getting the attention and participation of your students. In particular, we are going to share to you the steps on how to make a teaching and learning aid that you could use when teaching parallel lines cut by a transversal, which is, from the learning competency, the learner derives relationships among angles formed by parallel lines cut by a transversal using measurement and by inductive reasoning. Before anything else, let's first break down the title of the topic by defining the most important words and phrases included in it, starting with parallel lines. According to the self-learning module written by Ana Christie P. Mercado in 2020, parallel lines are coplanar lines that do not intersect, meaning they don't meet at a certain point. On the other hand, a transversal line is a line intersecting two or more coplanar lines at different points. So it basically looks like this. With that said, when this transversal intersects the parallel lines, certain angles and angle pair relationships are formed. We have interior and exterior angles, vertical angles, alternate interior and alternate exterior angles, corresponding angles, interior angles on the same side of the transversal, exterior angles on the same side of the transversal, and other supplementary angles. This is what the instructional material would revolve around. The IM would be used by the teacher to creatively present some examples of angles and angle pair relationships formed when a transversal line cuts parallel lines, and simultaneously, it would be used by the teacher to assess the students' understanding of the topic by letting them pick and answer the questions from the IM regarding the said topic. With all that said, when teachers discuss this lesson to learners who freshly transitioned from being elementary pupils to high school students, having vibrant conventional materials is the way to go, because it could engage the students to learn the topic, as they are still in the phase of their lives where they could still be intrigued by these kinds of teaching and learning materials. So, without further ado, let's start with the tutorial. To make this, here are the materials that we need. That being said, let's proceed with the steps. So, here is the final look of the instructional material. As we can see, the main element is the rotating lines. This is a great feature in the IM because it would make the learners realize that there isn't just one depiction of parallel lines cut by a transversal, but there is a variety of how they may look like. The plastic covered base is also a good feature because the teacher could emphasize that the numbers that represent the angles can be interchanged, as they are not fixed. We also have the mini treasure chest made of popsicle sticks, which holds the questions about the topic. With the help of some leftover art materials, we have made a more attractive, interactive, and fun version of the normal chalk written transversal and parallel lines. Now, how do we actually use this? This instructional material is actually just very easy to use. After presenting the students with the lesson by using the IM as well, the teacher could then rotate the lines, interchange the numbers representing the values of the angles in order to have variation, then call upon some students to come in front, get a question from the treasure chest, and answer what is asked. Now, why don't we try to enter a classroom and see the scenario?
So, as I said a while ago, 3 and 2 are vertical angles. They have equal measurements. So, if angle 3 is equal to 60, therefore angle 2 is equal to 60 degrees as well. These numbers can be interchanged. So, let's interchange them so that we can have another example. So, for instance, we have this. Let's put the numbers in brackets. Okay, so here is our example. So who would like to answer to start it? Can you pick one from this so that we can answer this one? It's the measurement of angle 3 and measurement of angle 8 equal to function. Are corresponding angles, therefore, their measurement are equal. So let's get started.